this data, which is going to be between the tension and the extension. So first we have to create another table or to complete this table, and we'll consider the tension, which is going to be on the y-axis, and the extension is going to be on the x-axis. Right, then we have to complete the table. First, before completing the table, the sum, taking the sum of the y's of this data, which is going to be taking the sum, you click on the option on the sum, and then you just click on the sum and then enter. So you'll get 93.5 kilonewton. Then we will add up the extension values, because we will need them when we use the formulas, which is the sum of y and sum of x. The sum of x, when we add them up, so we will use the same function, which is the sum, and then enter. You'll get 80 millimeter. That's the sum for the extension and the for the tension and then the extension. Then you have to complete the table, which is the y squared enter squared, and you will end up with and then you are going to square this value raised to the power 2. You end up with 20.25, and then you are going to do the same to the rest of this column of the tension. So I'll end up with those values. Then we will do the same to the x, but that's going to be squared, of course. And we are going to equal 3.8 raised to the power 2, enter, and then you'll end up with this value, which is 14.44. We can do the same by just using the same function, using the same formula, and then we apply it to the rest. Then what we are going to do, we are going to add them up. So using the sum function, we are going to add them up. We end up with 1807, and we do the same with the x squared, which is going to be the sum, enter, 1295.66. We do the same when we multiply, let's say, x times y to complete the table, so we can use those values in our formulas later on. So x times y, which is going to be equal the value of x, which is 4.5, times shift, and you click on shift and key 8, and then you choose the 3.8, then enter. You end up with 17.1, and you are going to copy the same formula and drag it all the way down. You will end up with those values, and you are going to add them together, add them up by choosing this, click on this sum function, and then enter. So those are going to be your values. You are going to use them in your formulas. Next we have to draw the linear regression line, which is the best fit line. How can we draw the best fit line? Of course, we are going to select, we are going to click on insert, scatter, and then click on scatter, click on insert, charts, and then click on charts. You have this option which is called scatter. Then you have to go to the data, which is selecting data, and then giving you the option which is the add legend entries, add, and you have the X and Y entries. So your series name will be regression line, and the X values, as we mentioned, that's going to be the extension. So this column, not all of them, so you don't add, don't include the sum. You are going to include just the data, and then we will do the same with the Y values, which is going to be the tension. The tension is going to be including all those values. You are going to select them. Then you click on enter. Then you click on enter. Okay. So you have the X and Y values right now. So we mentioned how can we draw a straight best fit line. That's going to be, you have this the plus. So if you click on this chart, and then you have multiple choices, you go to a trend line, it's called. You go to trend line, click on trend line, and you go to more options. When you click on more options, you have this, you have to click on the linear choice, linear, and then you scroll down, and it's saying that display the equation on the chart, which is going to be the linear equation, which is the for the best fit line. So you have to click on this option to show this equation, and then you have to, okay, let's go back, more options, and then you have to display the R, which is the correlation. So you end up with the R square is 0.977. That's going to be the correlation, and you have to compare it with, of course, your hand calculations, and make a comparison later on. Once you've done that, that's going to be your best fit line. Close the window, and you got this graph, which is between the between the extension and between the tension. You can add up the legends or the axis titles. So it's going to be horizontal. You can write down, that's going to be your extension, which is on the y-axis, which is in millimeter. And then you go back, you click on the chart, click on the more options, and you go to axis titles, and then you go to vertical, primary vertical, and then you type in the tension, which is in kilonewton. Then you are done. Can go to charts and then make it Okay, then you can change, that's going to be the most important thing, that's going to be your linear regression, which is going through all those data between the tension and extension. So this is your linear equation, which is y equal mx. When we mentioned y equal mx plus c, so that's going to be, the m is going to be 1.22 x and minus 0.72, that's going to be your y-intercept. If you maximize it, 12, the same as the your correlation value. Okay, right. So yeah, that's it. That's the best fit line is that's the best fit line, which is falling between those falling between this scattered data, and you have this is your linear equation, and this is your uh, correlation value. And when you taking the square for both sides, you end up with r equal 0.989 when you do work it out by calculations. The sum of these values, you will need them, of course, in your formulas, when you apply your formulas. All the best. Thank you.